So today we're going over the quiz for exponents and division. Write each expression using a single exponent. So the first way I'm going to show you, there's two ways that I'm going to show you. The first way is if you forget the shortcut, you can write it all out. So on the top here, we have x to the 8th power. That tells us that we are multiplying x 8 times. 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, we have x squared. That means we're doing x times x. It's 2 times. And then you can cross out whatever's on the top and the bottom. That's the same. And so this leaves you with 1, 2, 3, 4, 5, 6 x's in the top. So our answer would be x to the 6th power. That's the way that will always work. But if you remember a shortcut, there's a little bit of a shorter way. The shortcut says when you divide with the same base, so it's really important that the base has to be the same, but in this case, the base is x. When you divide with the same base, you can subtract the exponents. And 8 minus 2 is 6. So if you remember the shortcut, that might be a little bit faster, but it's always okay to write it out. All right, so let's try this one. H to the 12th tells us that we have 12 h's on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And those are all being multiplied, so I just pushed them all together. On the bottom, we have 5 h's. 1, 2, 3, 4, 5. And then you can cross out whatever's the same on the top and the bottom. And then count how many you have left. In this case, we have 1, 2, 3, 4, 5, 6, 7 h's left on top. So that would be our answer. You can also take the shortcut. Since we're dividing with the same base, h, you can subtract the exponents. All right, again, we're dividing with the same base. So I'm going to do it the long way first. On the top, we have 4 3's. 1, 2, 3. On the bottom, we have, I said that wrong. We have 3 4's. Our base is 4, and we have 3 of that. On the bottom, our base is 4, and we have 6 of them. 1, 2, 3, 4, 5, 6. Now, whatever's the same on the top and bottom, you can cross out. And in this case, we're left with 3 4's on the bottom. It's really important that you leave them on the bottom. Since there's nothing left on top, we can put a 1 as a placeholder. All right, you could have also done this by subtracting. You keep the base the same, and you do 3 minus 6, which gives you a negative 3. But we can't have a negative exponent, so the way we learned earlier was that if you have a negative exponent, you have to move it to the bottom and make it positive, and then put a 1 on top. In this case, I think it's a little bit easier to visualize and to just see why the 4 to the 3rd gets left on the bottom, because that's where they are. Now, since this is numbers, we want to go ahead and simplify this further. So 4 times 4 times 4, or 4 to the 3rd, is really 64, because 4 times 4 is 16, 16 times 4 is 64. So the final answer here would be 1 over 64. And now you can do this one in your calculator. You can't do this last one in your calculator because it had letters. But since this one is just numbers, you could do 4 to the 3rd divided by 4 to the 6th. Let's look at this. 4 raised to the 3rd is 64. 4 raised to the 6th is 4,096. And if I divide those, 64 divided by 4096, I get this really long decimal. Well, that's kind of ugly, but remember, you can change it back to a fraction by hitting that blue fraction button, and that tells you it's 1 over 64. Now again, I'm kind of partial to this method. I think it's easier just to write them out, cross them out, see what's left. All right, simplify this expression. We have 15 raised to the 0 power. There's no letters there, so we can type that in. 15 raised to the 0 is 1. Y'all, everything raised to the 0 is 1. It doesn't matter, it doesn't matter if it's 2,000 raised to the 0, or if it is negative 20 raised to the 0. Oh, I didn't put parentheses there. Sorry, guys, that should have been in parentheses. It doesn't matter what it is. Anything raised to the 0 will equal 1. Even x raised to the 0 will equal 1. So You don't really have to type those in your calculator. You just need to remember that anything raised to the 0 power equals 1. Which symbol makes the statement true? All right, so let's simplify this one. We have 4 7s on top. We have 2 7s on bottom, cross out, and we're left with 7 times 7 on top. You could write that as 7 squared, or you could say 7 times 7 is 49. So if we simplify this, we get 49, and we're comparing 49 to 49. Well, those are equal. Multiply the following polynomial. All right. So there are 2 ways that we like to multiply. We can either distribute, which I'll show you over here, or you can do the box method. Let's distribute first. So I'm going to take this negative 3r and I'm going to multiply it by each thing in the parentheses. So I'm going to do this part first. I'm going to have negative 3r times 8r. And then I'm going to multiply it to the back things. I'm going to have negative 3r times 5. And you can type in the number part in your calculator, just not the letter. So if you do negative 3 times 8 and you're like, oh, I can't remember, is that positive, negative 24? What is that? You can come over here and you can do negative 3 times 8. That's negative 24. But then you have to remember that since you have r times r, there's 2 of them, so that's really r squared. And then here we have negative 3r times 5. So you multiply the numbers. Negative 3 times 5 is negative 15. And in this case, there's just 1 r, so you just put down 1 r. And then we try to combine like terms, but you can't combine r squareds with r's, so this is our final answer. You could have also used the box method. This is a 1 by 2 box. The one term is negative 3r. The binomial, or the 2 terms, is 8r and positive 5. And then you fill in the box by multiplying. 8r times negative 3r is negative 24r squared. This one's negative 15r, and you can see that you get the same answer whether you distribute or use the box method. So that's up to you. So let's look at another multiplying problem. So I'm going to come over here and distribute first. So I'm going to take my 4a and I'm going to send it to everybody inside the parentheses. So I'm going to start off by doing 4a times a squared. And that would give me 4, and then there's 3 a's, right? Because there's 1 a here and there's 2 a's there. So that ends up being 3 a's. Now I'm going to take my 4a and multiply it times 5a. 4 times 5 is 20, and I have 2 a's, so that's a squared. Now since I don't have a sign here, since it's a positive 20, I'm going to put a plus sign. And then I'm going to distribute the 4a to the 2. 4 times 2 is 8, and there's only 1a, so I just put 1a there. Since this is positive, I'm going to put a plus sign. And then I'm going to see if I can combine any like terms. I have a to the third, no other a to the thirds. Then I have a squareds with no other a squareds, and then I have plain a's. So none of those can be combined, so that is your final answer. If you wanted to do the box method here, it would be a 1 by 3 box with 1a on this side, and then you'd have a squared, 5a, and 2, and then you could fill it in that way. All right, when we get to a problem like this, if we think about distributing, we have a lot of distributing going on here. We have to do the 2y times 3y, and that would give us 2 times 3 is 6 with 2y, so y squared. Then we have to do the 2y times negative 2, which would be negative 4, and then there's just 1y. But we're not done. We also have to distribute the negative 5, so we'd have to do negative 5 times 3y, which would give us negative 15y, and then we would have to do the negative 5 times negative 2, which gives us a positive 10. So we have to distribute the first term to each of them, and we have to distribute the second term to each of them. And then we're going to try to combine like terms. I have a y squared here and no other y squared, so that one I just write down. Then I have a minus 4y and a minus 15y. I could combine those, and that would give me a negative 19y. Now notice when you're multiplying y times y, it becomes y squared. But if you're adding y plus y, that just gives you 2 y's. So this does not become y squared. I am just combining them. I have negative 4y's minus 15y's is negative 9y's. And then we'll just bring down our plus 10. Now for a lot of people, the box method is easier when you get to binomials. Binomials means that there's 2 terms in each of them. And I actually like the box method better too, because when you distribute, you tend to forget where you've distributed and where you haven't. So box method is actually my favorite. I'm going to take this first binomial, and I'm going to put 2y and a minus 5. Then I'm going to look at my second binomial. I'm going to put 3y and a minus 2. And then to fill in the box, this first space, we have 2y times 3y, that's 6y squared. Here we have 3y times negative 5, that's negative 15y. Over here we have negative 4y. And then here we have positive 10. The cool thing about the box method is when you go to combine like terms, you can kind of already see there's a plus sign. This kind of makes a plus sign. So I write down this term first, so 6y squared, and then I combine or I add my like terms. So negative 15y plus negative 4y, that's negative 19y, and then I just bring down my last one. So that is the answer for box method. Notice it's the exact same whether you distribute or use a box. From here on out, oh, that was the last one. I was going to say I'm just going to use boxes moving forward, but that was the last one. Good luck on this quiz.